Okay, this is a practice quiz for Algebra 2 Honors. And it's written out. I put them all one slide, and we're going to work them all out right now. Number 1, you want to add or combine, basically simplify. So you have 3x squared and 1x squared. 3 and 1 make 4 of them. You have a negative 5x and a positive 2x. Negative 5, positive 2 is negative 3. Then you have a positive 2 and a negative 6. If you just combine 2 and negative 6, I think you get a negative 4. Hopefully that's the answer for number 1 upon addition. Now number 2 is subtraction. I'm just going to rewrite the first part. And then I'm going to distribute the negative 1 here. That just changes all these signs. So that's going to be a minus 2x, and that's going to make it a plus 1. Now you have an x to the fourth. That's the only x to the fourth there is. How about negative 2x cubed and another negative x cubed? That should be negative 3 of them. Any x squareds? I don't see any x squareds. Minus 2x, I think that's the only x. But you do have a 7 and a 1. 7 plus 1, I hope, gives you an 8. And hopefully this is the result of that subtraction in number 2. Okay, let me continue then. So let's distribute 3a times a is 3a to the second. 3a times a b becomes 3ab. Now think of this as a negative b times a is a negative ab. And negative b times b is negative b squared. So you add 3a squared. These two middle terms combine a lot of times, so you have 3 and a negative 1 making 2 of them, and minus b squared. Now if you're really good on this next one, you might recognize it as a minus b times a plus b, which is going to yield the difference of squareds, a squared minus b squared. So basically that means the 2x is squared minus and the y is squared. Don't forget to square the 2 as well as the x. And I think you'd get this result if you're following the formula. If not, you can always distribute. So let's distribute. 2x times 2x is 4x squared. 2x times a y is a positive 2xy. Negative y times 2x is a negative 2xy. And negative y times a positive y is a negative y squared. 2xy and negative 2xy add to 0, leaving me hopefully the same answer I got by using my difference of squares formula over here. Okay, if we're okay through 4, we're going to move to number 5, another multiplication. Negative 2x times a positive 1x squared gives me a negative 2x raising the power, adding the exponents, 2x to the third. This would make a minus 10x to the second, and this I think is going to make a positive 6x. And that should be the result if we distribute. Number 6 is the division. We could do these long or synthetic. 3x, let me move it over so we have room. 3x cubed minus 4x squared plus 5x minus 2 is divided by x minus 1. So x times what number up here equals 3x cubed? X times what is 3x cubed? Well, that would be a 2x squared. 2x squared times, I'm sorry, it'd be a 3x squared, wouldn't it? 3x squared times x. 3x squared times x is 3x to the third. 3x squared times negative 1 is a negative 3x squared. When you divide, you have to change the sign and add. So that should make it a negative 1x squared. Bring down the 5x from above. X times what equals negative 1x squared? X times negative x is negative 1x squared. So this should be a negative x. Negative x times x is negative x squared. Negative x times 1 is a positive x. Again, you're going to change your signs and add. Hopefully these will subtract off. I'm sorry, what did I have? Where's that 5? I messed that up, didn't I? That should be negative x times 1 should be a positive x, shouldn't it? Did I change the sign? I think I got to change it to a negative, right? So when I combine those, I think I get 4x, and the minus 2 comes down from up here. X times what is 4x? Should be a 4. 4 times x is 4x. 4 times negative 1 is negative 4. Change the signs and add makes your remainder a 2. So you're going to make it into 3x squared minus x plus 4 plus your remainder over the divisor. Now, I hope I can get the same answer using synthetic division, because all powers are represented in decreasing order, x to the 3, x to the 2, x to the 1, x to the 0. Because that's the case, I'm able to do synthetic, bringing down the coefficients, 3, negative 4, 5, negative 2. Hopefully those are the coefficients of that. Then you draw a line, leave a space, draw a line, and make a box. The number that goes in the box is whatever makes this 0, which would be a 1. Bring the first number down and multiply. 3 times 1 is 3. Put it here and add. Negative 1. Multiply would be negative 1. Put it here and add. Multiply would be 4, and put it here and add. That makes the remainder 2. So that's 3x to the, we started with a third, so it's x to the second, minus 1x plus 4 plus the remainder over the divisor. Now I hope that matches the previous one. Let's check them, see if these are the same. The one on the left is called long division. The one on the right is called synthetic division. You can only use synthetic division when what this equals 0 is an integer. Okay, if we move to number 7, it's another division question, but all powers are not represented. X to the 3, x to the 2. There isn't an x to the first, so we might have to rewrite this. We have x to the third plus 5x to the second plus 0 x's minus 4. You might need that for a placeholder when you're doing the division. And we're dividing it by x plus 3. So x times what is x to the third? Well, x times x squared. X squared times x is x to the third. X squared times 3 is 3x squared. Change your signs and add. This will become a 2x squared. I'm going to bring down this 0x in case I need it. So x times what is 2x squared? X times 2x. So up here is a positive 2x. 2x times x is 2x squared. And 2x times 3 is 6x. Again, change your signs and add. If you didn't have that 0 there, you wouldn't have a place for it, or a column that is. When you combine these, you get a negative 6x, and I'll bring the minus 4 down. X times what is negative 6x? X times negative 6 is negative 6x. So x times negative 6. Negative 6 times x is negative 6x. Negative 6 times 3 is a negative 18, I believe. And if we change the signs and add, the remainder is going to be here, what, 14? So you take it, answer would be x squared plus 2x minus 6 plus the remainder over the divisor. I'm hoping I can get this same answer using synthetic division. Okay, I'm going to attempt the same question using synthetic division. All powers are not represented in decreasing order, so I have to make them. So the first coefficient here is a 1. So I have a 1, a 5x squared, 0x, and a minus 4. Leave a space, draw a line, make a box. The number that goes in the box is whatever makes this 0. In this case, negative 3. First number always comes down, then you multiply. Negative 3 times 1 is negative 3. Put it here and add. Negative 3 times 2 is negative 6. Put it here and add. Negative 3 times 6 is 18. Put it here and add. That means 1x squared plus 2x minus 6 plus your remainder over the divisor. Unless I made a mistake, I'm hoping these two should be equivalent. Looks like they are. Okay, let's move on to 8. We want to know whether these are inverse functions. We could switch x and y and solve for y, see if it matched, or we could do what's called composite function. A composite function, which is what we're trying to get at, is I'd like you to do f of g of x. Basically, you take this, your original, and you rewrite everything except for the variable. You replace the variable with the other expression. So, I think 3 and negative 3 eliminate. Oops, I should have replaced it with what? If I'm replacing x with the other expression, isn't it x squared minus 3? So don't I end up with just x? Therefore, they are inverses. If you simply get x, that means they're inverses. If you do f of g and you just get x, they're inverses. Another way is to realize this original one was what? Y equals radical x plus 3. How do you find inverses? You switch x and y, so I'm going to switch x and y and solve for y. So I square both sides and I subtract 3. Does that match this? Yes, they are inverses. So you could either switch x and y and solve for y to see if they match, or you could do a composite function to see if it equals x. Since we are doing composite functions, I've been pushing you to do the composite way, but that's up to you. 9 I'm doing the same way, but it's just a line. So if I was to take my function, let's do f of g of x, replace the variable or the letter with the other expression. So I want to replace this with 3x minus 6. When I clean this up, I get x, 6 over 3 is 2, those eliminate. I get simply x. If it's simply x, the answer is they are inverses. Again, you could take one of them, like this, or this over here is y equals 3x minus 6, right? Switch x and y. If I switch x and y and solve for y, that's how you find an inverse. Switch x and y and solve for y. You would add the 6, so you'd have x plus 6, and then you'd have to divide by 3, x plus 6 divided by 3, and I think that matches your other equation. So again, they are inverses. Okay, 10 was over here. They want us to actually find the inverse. Right now it says this. To find an inverse, you're going to switch x and y. So I need to switch that. Y becomes an x, the x becomes a y. So you do two things. You switch or swap x and y, and then you solve for y. So I switched x and y, now I'm about to solve for y. If I add 7, and then to get rid of the square, you take the square root. And that's the inverse. Many times the inverse is written with an f with a -1. But whatever you get after you switch x and y and solve for y, that will be your inverse. So again, to find an inverse, you want to switch x and y and solve for y. Okay, the composite functions. I gave you f and I gave you g. This one right here means f of g of 2. It's just a different way of writing it. Can anybody put 2 into the g and tell me what I would get out? What is g of 2? If you put 2 in, 2 minus 3, would it be -1? So now I need f of -1. Replace the x with -1 in the f function, and let's see what we get. Squaring that is 1 times 3, and I think that becomes +2. So I'm hoping this result should be 5 for 11. Again, we found g of 2 first. To find g of 2, you're going to replace the x with a 2, and that's how I'm getting g of 2 to equal -1. And then you want f of that -1, so you put -1 into the f function. Make a little bit of room here. Okay, now we're asking for something a little bit different. I want g of f of -1. Do we know what f of -1 is? If you put in a -1, we just found it to be 5, didn't we? If you put in a -1, I think you get 3 plus 2 or 5. So now I need g of 5. Replacing in the g with a 5 makes this result a 2. So again, we found f of -1 by plugging the -1 into the f, and then we took the result that we got a 5 and did g of 5 by plugging 5 into the g function. Those are numeric ones. Let's do one that's not numeric like this one. Says f of g of x. Take your f function. That's 3x squared minus 2x. and you replace the variable with the other expression, in this case x minus 3. So you have to expand it. You're going to square it first. The process would be square the first, square the last, twice the product, that'd be negative 3x, doubled is negative 6x. If I distribute this negative 2, I'd have negative 2x, I think, plus 6. So I have to distribute this 3 after I squared it. So that's 3x squared minus 18x plus 27 minus 2x plus 6. So I believe this is going to yield what here? 3x squared. Negative 18x and negative 2x is negative 20x. How about 27 and a 6? I think that's 33. And hopefully that's what we get. So basically you take the f function and replace the x with whatever the other expression is, g. I hope this helps. Good luck.